From the very shirt on your back to the sofa you're sitting on, woven fabric is, well, it's everywhere. But have you ever stopped to think about how it's actually made? Today, we're going to dive into the incredible technology that turns simple threads into the textiles that literally shape our world.
No, really, go ahead and take a look. That shirt, those jeans, they all started out as just a bunch of threads. The journey from a simple spool of yarn to the fabric you're feeling right now, it's an absolute masterpiece of engineering, one that's been tweaked and perfected for centuries. In this, right here, is the fundamental puzzle. At the end of the day, every piece of woven cloth is just a simple grid. You've got these long threads, the warp, and the threads going across, the weft. The entire science of weaving is basically obsessed with solving one problem. How do you interlace these two sets of threads efficiently and perfectly, thousands upon thousands of times?
Well, the first big industrial-scale answer to that puzzle was the classic shuttle loom. This machine took a process that had been done by hand for thousands of years and turned it into an automated powerhouse. It completely changed everything.
Okay, so to get how any loom works, you just need to understand these three core actions. First up is shedding. That's where the machine lifts up a specific set of those long warp threads, creating a little tunnel or shed. Second is picking. That's when the weft thread gets passed through that opening. And third, beating up, where this comb-like part slams that new thread into place. Shed, pick, beat. That's the rhythm of weaving.
And here you can see that rhythm in action. It's just a brilliant display of mechanical precision, isn't it? See how the warp threads are separated to make that path for the weft? Then, bam, the beating up motion compacts it all into that tight weave we all know. It's like a symphony of moving parts, repeating those three steps with unbelievable speed. But you know, as revolutionary as they were, these old-school shuttle looms had some serious drawbacks. For one, they were insanely noisy. We're talking factory floors so loud you couldn't even think straight. They were also power hogs, and, well, there's a physical limit to how fast you can fling a heavy wooden shuttle back and forth. It was pretty clear that engineers needed to come up with something new. And that challenge, it sparked this incredible burst of creativity. It led to a whole new generation of shuttleless looms, and each one had its own clever, new way of getting that weft thread across the machine as fast as humanly or mechanically possible. And just look at the genius solutions engineers came up with to ditch that clunky old shuttle. You've got the projectile loom, which literally shoots this little metal gripper carrying the yarn across. Then there's the rapier loom, which uses these long, thin rods, like a fencer's rapier, to hand the thread off in the middle. And then things get really fast with airjet and waterjet looms, which use a super precise blast of air or water to fire the yarn through the shed. Each one is a clever answer tailored for different kinds of yarn and fabric. So once engineers totally nailed the speed problem, what was the next frontier? Well, it was complexity. How do you go from making simple grids to weaving these beautiful, intricate designs right into the fabric itself? The secret is all about how you control that first step, the shedding action. The most basic method is called tappet shedding. Honestly, the best way to picture it is like an old-school music box. You have these rotating cams, the tappets, that push levers up and down in a fixed pattern. It's super simple, really reliable, and perfect for basic stuff like the plain weave of a bedsheet or the diagonal twill of your jeans. But it's pretty limited. Now we're leveling up. A big step forward is the Davi mechanism. This is a much more complex system that gives you control over way more of the frames that lift the warp threads. We're talking up to 40 of them. This is what lets you create fabrics with those small repeating geometric patterns, like a cool honeycomb weave or a bird's eye pattern. But for the absolute top tier, ultimate in pattern control, you need the jacquard mechanism. This thing was a total game changer. It's often called a forerunner to modern computers because it originally used punch cards to dictate the pattern. It gets rid of the frames entirely and instead can control every single warp thread on its own. This means the design possibilities are, well, they're basically infinite. This is how you get those incredible tapestries and fancy brocades. Okay, so we've got speed solved and we've got complexity solved. But there's one last piece of the puzzle, and it's a huge one: perfection. When you have a machine this complex moving this fast, even the tiniest little mistake can have a big impact. And trust me, a lot can go wrong.
You might get a slub, which is just a random thick spot in the yarn. A warp thread, an end, could snap, leaving a visible line. The machine might accidentally shoot 2 weft threads through at once. Every single one of these little hiccups can create a flaw you can see in the final fabric. And this quote right here just hits the nail on the head. In the world of textiles, quality is absolutely everything. A small repeating flaw can make an entire roll of fabric totally worthless. This constant fight for perfection is what drives all the innovation and quality control in mills around the globe. So the next time you pull on a t-shirt or sit down on your couch, just take a second to look closer. Think about that incredible, lightning-fast dance of shedding, picking, and beating up that brought it into existence. It's one of those quiet, everyday marvels of engineering that really does weave our world together. Thanks for joining us.